Good morning to all. Myself, Dr. Arunagamiya from Aerospace Engineering Department. Today, I am going to take one topic from Aerospace Propulsion subject. So, if the topic, it will be taken for the second year Aerospace students. Topic name is for performance and efficiency characteristics of gas turbine engines. So in that cases, for empathize spot the while fuel economic challenges in aerospace gas turbine engines. So it can be the main reason is following three reasons only. First one is operating cost impact. Second one is progress made. Third one is future target. So in that first one is for aviation fuels, more amount of 30% of aviation fuel cost. So generally, for example, the for ticket fare is around the 30 to 50% of ticket fare. It will be fall under for the airline fuels only. And next one is for progress made. The 50 to 20% of fuel reductions it will be utilized for the 20 years. And next one is future targets. So for NASA high tech, the 5 to 10% of reduction by 2035. So by implementing the by NASA research, it can be reduced the utilization of fuel 5 to 10% in 2035. And by defined part, the defining the efficiency in gas turbines. So generally, the efficiency it can be classified into three types. First one is overall efficiency, and the second one is thermal efficiency. Third one is propulsive efficiency. For overall efficiency, it can be denoted as neta suffix O. So it can be defined as the ratio of propulsive power by fuel energy input. And the second one is the thermal energy denoted by neta suffix th. So it is a conversion of fuel chemical energy into kinetic energy. And the third one is the propulsive efficiency denoted as neta suffix p. So here the conversion of kinetic energy into thrust. And by relating this efficiency, so overall efficiency equal to thermal efficiency and propulsive efficiency. And the thermal efficiency, it can be explained by the engines. So in that cases, the four engines, it can be classified by four different compound areas like compression, combustion, expansion, and exhaust. So here by thermal efficiency, the more amount of heat it can be generated in that turbine area only. So in the around the 45% of air it can be found in that turbine area. So in that cases, we will utilize the high temperature materials for particular area. Next one is the propulsive efficiency and its importance. So in that cases, it can be the four categories are utilized for the propulsive efficiency. First one is the velocity relationship. So in that it will be relate between the exhaust velocity and air gust speed. So what are all the efficiency? It will be vary fall under the two parameters. Second one is the turbojet challenges. So in the turbojet challenges, the low propulsive efficiency it will be found at the subsonic speed. So because of the high exhaust velocity, it can be found in that area only. For turbofan solutions, the air moves at a lower velocity for better efficiency. And next one is the loss analysis. So in that loss analysis, what are all the efficiency leak it will be found. First one is the aerodynamic losses. So in that aerodynamic losses, propel drag it will be found in that area. Due to this case, as the tip leakage and flow separations, it will be found in compressor and turbine region. And next one is the combustion in efficiency. So here in that cases, the incomplete burning it will be happen in that combustion chamber area. For mechanical losses, the bearing friction due to these cases, the losses it will be found in the bearing area. For thermal losses, the more amount of heat it can be found in that turbine area. So in that cases, we will utilize for the some cooling air or cooling methods. It will be used for these cases. For visualization of losses, so the comparatively for compressor area, the more 50% of loss it can be found in the compressor area. So because the more amount of air it can be compressed particular area only. Compared to the all the losses, the cooling air bleed losses have the very low compared to the odds. So thank you. So we will catch you on the next topic on next video.